Today we're doing a deep dive into one of those big headaches for broadcast engineers. How do you move multiple streams of uncompressed, high-def video over really long distances without, a total mess of cables? We're going to be looking at the Thor Broadcast F-6SDI-3G-TxRx-RM system. And our mission really is to unpack how this one piece of hardware gets 6 channels of 3G-SDI video over a single fiber strand.
And that's the key, right? The preservation of the signal. We're talking about SDI, serial digital signals at up to 3.0 GBPs. This isn't like IP transport. The S6SDI, it sends everything uncompressed.
Including all the metadata.
Everything. Embedded audio, timecode, all that critical ancillary data for things like camera control. For live production, that uncompressed, low-latency signal is it's non-negotiable. Zero degradation is the goal.
Okay, so let's break down the hardware first. Physically, what are we looking at?
It's a simple kit, really. A transmitter and a receiver, and they both fit into this sleek 1RU 19-inch rack-mount chassis.
Simple form factor. But the big win here seems to be the deployment.
Oh, absolutely. It's truly plug-and-play.
Really?
Yeah, that aspect is a huge labor saver. The documentation is clear. You don't need to configure or manage anything. The system just it automatically senses and adjusts to whatever signal you feed it. Bitrate, protocol, doesn't matter.
That almost sounds too easy. I mean, in engineering, that can sometimes be an alarm bell. You're dealing with all sorts of different broadcast gear. Doesn't that auto adjustment introduce some risk with, say, non-standard byte rates?
It would if the underlying tech wasn't so robust. See, the unit is built with commercial-grade parts. It's TAA compliant, has a 2-year warranty. They've basically put all the engineering effort into the signal conditioning inside the box, so you, the user, don't have to manually tweak settings in the field.
Okay, so let's get to the core of it. Moving 6 channels over one fiber. That all comes down to CWDM, right? Of course, wavelength division multiplexing. How does that actually work?
CWDM is really the workhorse of modern fiber. Think of it like this. Instead of needing 6 separate fiber cables, one for each video channel, CWDM gives each of those 6 SDI feeds its own specific color of light or wavelength. Then it bundles all those different colors down the exact same piece of glass.
So you're basically replacing a huge bundle of cables with one.
Precisely. A broadcast center can just drastically shrink its infrastructure footprint.
And it scales, I imagine. 6 channels is standard, but what if you need more?
You can order custom setups, like for bidirectional transport, and get up to 16 total channels. And if you need even more density, they offer DWDM options.
Right. And what about distance? That's always the next question.
Yeah.
This is built on a 40-kilometer platform.
Correct. And when we talk range, it's all about the optical budget. Standard is 25 dB, which gives you plenty of headroom for splices and things over 40K.
But there's a long-range option.
Yep, for those really long runs, you can get a 35 dB version. It lets you push the physical limits much, much further.
And for the engineers listening, the connectors are standard.
All standard. STPC for the fiber, BNC 75 ohm for the electrical side.
Let's circle back to reliability. You mentioned signal conditioning. That brings up input equalization and reclocking. For anyone dealing with long copper SDI runs before you even get to the fiber. Why is that so important?
Because copper it degrades high bitrate SDI signals. Over a long cable, the signal's timing, the clock, it gets messy.
Right.
The reclocking and equalization in this box essentially cleans that signal up. It resets the timing, fixes the amplitude, and ensures that what goes down the fiber is a perfectly pristine digital feed.
And it seems like it's built to last outside of a perfectly climate-controlled server room, too.
For sure. It's rated for an operating temp from -10 Celsius all the way up to +55 C. It's designed for the field.
So at the end of the day, what this system really does is solve that massive problem of moving uncompressed video efficiently. It uses CWDM to get the density, but combines it with a super simplified automatic deployment.
And if you connect that to the bigger picture, the ability to use that whole spectrum of wavelengths from the 1271 nanometer band up to 1611, it just shows that spectral efficiency is the real key to building modern, flexible broadcast infrastructure.
So here's a final thought for you to chew on. Given this system works with any serial digital signal up to 3.0 GBPs and has these simple LED status lights for every single channel, how do those basic diagnostics streamline troubleshooting for a crew that's 40 kilometers away when they're trying to figure out if the problem is electrical, optical, or something else entirely? Something to consider.